Hi, I'm Sonny Alvestias, CTO in the gaming industry. Welcome to my podcast, aimed at software engineers, programmers, and computer scientists. In every episode, I'll put one of the best engineers working behind the scenes in the spotlight. Hi everyone, and welcome to a new episode. When I prepared my first episode with Sebastiano Mandalà, he gave me a name, and he told me if I am into ECS, I should likely also talk to Adam Martin. So my guest today is Adam Martin. He formalized the concept and the paradigm behind ECS, but not only, really. So Adam has a pretty long career with multiple facets to it. So I'm very glad to welcome him today. Hi, Adam.
Hiya.
Would you mind to give us a brief intro of yourself?
Sure. So thank you very much for having me. It's great to talk about this. I'm Adam. I am currently a CTO for early stage companies and part-time writing a book on culture and hiring, but mostly focusing on the CTO work.
Nice. That's interesting. What is your background and what actually brought you into computer science and programming and such?
Yeah, so my walk into computer science was a bit random. I tried programming when I was about 10 or 11 years old, and I couldn't do it. I sucked. I couldn't actually understand a lot of the concepts. It was very difficult. I tried again when I was about 15 or 16 after seeing one of my friends at school wrote a 3D software renderer. This is many, many years ago. This is in the 1990s on an Acorn Archimedes. My mind was blown. I was like, how? This is magic. What has he done? And then he just said, but it's so obvious. And in the space of about 30 seconds, he explained to me how to write most of a 3D engine. And I just thought, this is magic. How can it be so simple? He essentially said, all that stuff you've been learning in your maths lessons, it's useful. It actually has a use. That guy was Jamie Falston, who went on to ended up working for Sony, did a lot of PlayStation and PlayStation 2 games, and wrote, I think the stunt was a lead programmer on some of the racing games, and still works in the computer industry, but I don't think he works in games anymore. So I had another go at programming and learned to write very simple 3D engines that sucked, but they were real time, and it was quite fun. When I left secondary school, I was a very introverted, nervous, scared, stereotypical geek or nerd, I suppose. And I had the opportunity to apply to Cambridge University. I wasn't sure I wanted to go, but I looked at the courses and I looked at the computer science course and thought it fitted with so much stuff I already knew that I would feel less nervous about going and interviewing for that degree subject. The school I was at was a very strong maths school. I was in the top set and I had been intensively taught a lot of advanced mathematics through my last few years at school. And I thought, yeah, this won't be so scary. I can do this as a practice. Obviously, I will never get an offer. I won't get in, but then I'll be a bit calmer about applying to other universities for other degree subjects. So I went along to the interview. I did make some stunning mistakes. There was a point where I realized I had to divide the number 17 by the number 9, and I said the answer was 3. And then I got very embarrassed, and I went, no, and the guy looked at me a bit worried, and I said 1, and then he looked even more worried, and I thought, that's it, there's no way they're ever going to give me an offer. But they gave me an offer, and I ended up going to Cambridge, and from a computer science perspective, I think that was very good. It was the course as it was taught at the time, and I think still today pretty similar, is primarily a applied mathematics course, which happens to involve computers and computing science. They see themselves as a maths course first and foremost, and computers second, which means you get a very, very, very strong grounding in the theories of computing, computer science, computation, language design, compiler theory, all this stuff. And you get quite a lot of exposure to all the more advanced things like the theoreticals that underpin, or today, things like machine learning. You go into all of that as part of the undergraduate course. So if you're interested in the big problems and the big long-term problems in the computing world, it's that, and there's a lot of degree courses like it at other universities, but those that really focus on the theoreticals of computer science, a great starting point. The downside is that you come away a bit too theoretical, and it could take you some years to learn how to become pragmatic, especially in your use of programming. But I think that's an easier transition to make than the other way around, which is learning pragmatic first and then having to try and upskill yourself into understanding the often very esoteric and complex theory behind it. So it was fairly random in my case, but I think it worked out well because I think that fitted with my interests.
Nice. So what happened to you?
Before university, I took a gap year because, again, I was afraid that I wouldn't cope well with university and I needed a bit more exposure to the outside world and becoming a bit more independent first. So I took a gap year. I worked at IBM's research laboratories in the UK. And during that time, the second half of that year, I ended up working with a friend who'd founded a new IT consultancy, basically fixing computers for small offices and installing Windows for them and fixing their networks and just IT stuff. But because they had no one they could trust who knew anything about technology, a lot of them would then ask us to write small scripts and look after their backup systems and design how they would do the next version of the networking for their office. And we were doing that and making what for a pair of 19-year-olds was an insanely large amount of money. But we were doing it mostly in a consulting sense. And so, although it was very tempting to stay there, I realized that running a consultancy is extremely difficult. Every time you hire a new employee, that person has to be at least as skilled as the average of all your existing people, or else they will actually reduce the amount of money you're making because your customers are paying proportional to the actual knowledge of each consultant they work with. And that terrified me because we were struggling to find anyone who was anywhere near to us in terms of level of understanding of technology and our use in it. So I went off to university, and whilst I was at uni, I then got involved in the university that they'd started a new society for entrepreneurs. This was started by a senior guy or mid-level guy from McKinsey & Co. who wanted to get Cambridge University to run a degree course in entrepreneurship. And the university apparently had said, no, you'll have to spend 5 years of preparation and proving the need for such a course, etc., etc. And he said, or I can just come back, do a PhD, and while I'm doing it, I will set up a society and we'll turn it into a hidden degree course, which is what we did. So we ran our own lectures. We had hundreds of people go to our lectures each year, which was quite strange for a society at the university. And with all his connections in industry, he went off and he raised a few $100,000 of funding from big companies who we used as a prize pool. So we then did a business plan competition each year, and the top 5 to 10 business plans and teams got given cash to go and start their companies. So I got heavily involved in that and helping to run that and try and make it into a success and help the companies that were founded out of it. So by the time I graduated, I'd been addicted by this whole startup thing. And I took the technology I'd been playing around with as an undergrad, or some of the technology, which was around massive multiplayer online games. And at that time, I'd been part of the MudDev mailing list for a few years. And MudDev was a mailing list that grew out of a few friends in Silicon Valley area, I think, from memory, who were all professional game developers. And it had grown into being the place where everyone in the small MMO industry at the time hung out and shared ideas and problems and solutions. So you had lots of people who went on to be extremely famous. People like Raf Costa were members of it, and there was a lot of sharing about techniques and challenges and failures. So I've been on that list for a while, and I've got a feeling for even what the big commercial companies were succeeding and failing at. And I've been doing my own work of trying to reproduce those results and improve on them. So when I graduated, I thought, what's the worst that can happen? I'll try it myself. So I set up a new startup to try and commercialize and finish writing this technology. I massively underestimated how long it would take and how much it would cost. I got offers of funding. I turned down the offers of funding because I felt that they were going to take too much of my company, and I was sure that I could get a better offer. And then the dot-com crash happened and everything went horribly wrong. Along the way, I started experimenting with the different ideas of how you could compose data, because in order to do a very efficient, high-performance, distributed, scalable backend for these MMOs, you needed to cut data up into smaller chunks. And so this was the first attempt I made at what became an entity component system. It clearly worked a lot better in some ways. It had a lot of problems in other ways. And we were trying to build this in Java originally, and this was before Java could access native memory. So it had to all be done in normal user space memory. But what we did see was that it made our speed of writing new features for any game much, much quicker. And we were just a handful of people just doing this in my living room. But it clearly had some advantages. While I was doing this, I was living quite close to a guy called Andrew Gower, who had made this small game called RuneScape, which at the time had something like 12,000 users, I think. And I used to go and hang out with him and chat to him about his game, RuneScape. And he, at one point, he basically asked me to go and join his company and merge with him. And that could have been a very different path. The world could have turned out very differently. But in the end, I said no, stuck with what I was doing. Obviously, RuneScape went on to become this enormous juggernaut, for which I was very pleased to see Andrew's success with that. But the end point of this company was that I ended up winding it up about 4 years later, having paid off the debts and having got some patents for back-end scalability, which was great, but it meant that I had essentially wasted about 5-6 years of my life on some technology that no one was using, no one had deployed it. I had some patents that weren't licensed to anyone. I'd lost a lot of money, lost a lot of time. I really had nothing to show for it, which then drove me to going, what on earth am I going to do? Have I just destroyed my entire career? No one's ever going to want to hire me for anything. But fortunately, people did. And so then I went back and started getting jobs in the games industry itself.
Is it at that time that you formalized this concept of ECS, or it's after?
Absolutely not. So at that time, what I figured out was, for a game designer trying to write a game, there was a classic problem, which is you try and write it in C or in BASIC or something equally poor choice, or early JavaScript. That's just going to fail. It's far too, the languages aren't, or at a time, were nowhere near powerful enough to support the complexity of a game. So the code would work, but it was extremely difficult to maintain, extremely difficult to design or architect. And it ended up being very, very buggy and very difficult to fix the bugs. So everyone was like, oh, okay, you should use object-oriented programming. It's the big thing. It's been popular for 10 years. It's what professional programmers use. We should be using that to make games. Great. So then your designer would come up with, the base class will be a humanoid. You normally have a base class of human, which has a subclass of player and a subclass of enemy knight or something like that. And you're going fine. You go, oh no, actually I want an orc, and an orc isn't a human. So then you refactored your human class to be a humanoid class. And they have a humanoid base class with a subclass of human and another subclass of orc. And the human class has a subclass of player and a subclass of enemy knight. Okay, so that refactoring took a lot of time and effort, and almost every game went through this process. With a bit of experience, you ended up being a bit more careful up front and having more layers right from the start. So you thought, okay, fine, this is good. But then one day you wanted an orc knight, and suddenly everything broke, because there was no way of expressing that within an OOP hierarchy. There's many, many things you can do at that point, and they're all okay. But all of them, if you carry on building on that structure and expanding it further, it gets clunkier and clunkier. And sooner or later, you end up in a similar situation to writing your game in C, which is there's way too many globals. It's extremely hard to debug. It's full of bugs, and you waste more time in fixing existing features than in adding new features. And then we got as far as showing that the real problem there was that you tied functionality into classes and embedded it there. So there was no way of sharing subparts of a class across different classes. And there's lots of ways you can do that within OOP, but all of them brought new problems. And so we'd seen that the thing that was definitely true was that as a game designer or as a game developer, a game engineer, you wanted to avoid the situation of ever having classes and base classes where functionality relating to the game logic was held within those classes. You instead needed to do some form of
composition,
functionality by composition, rather than by inheritance. Once you go down that path, then it's very easy. Even within quite a strongly typed, rigorous, slightly academic language like Java, there's still lots of ways that you can do composition-based structures. Although you had to jump through a few hoops to make it work quite nicely. And then with Java 1.4.2, that one, which I think was later renamed to Java 4, we finally got direct access to native memory, and you could start doing those things very quickly at high performance, because you could actually just manipulate direct pointers in memory, and it started to approach the kind of speed as if you'd done that in C++. At that point, it's like, this is good. This is the right direction, but it still had a lot of problems. That was where I'd got to when we wound up that first games company. For me, the whole ECS thing didn't click until my second job after that. The first job was at a games company called Mind Candy, which went on to make Moshi Monsters some years later. Another big success, which was great. But after working at Mind Candy, I went to a games publisher called Codemasters. And while I was there, some of my colleagues on the PlayStation 3 side, PlayStation 2 and PlayStation 3, they'd shipped a lot of games on PlayStation 2. So these were hardcore C and C++ game programmers who'd spent years obsessing about the hardware and how to use it, and how to take advantage of it. And they were playing around with a packet-structured execution system, which made sense from the PlayStation hardware perspective. So the nature of PlayStation 1 and everything that came after it was that it was very good at streaming. This is a gross simplification. I'm sure other people will correct me on this, but it was very good at streaming, and it wasn't so good at holding lots of big structures in memory. It was memory limited. So you wanted to have something that made it very efficient for you to pull the subset of data you needed to work on in the current frame out of wherever it was into your CPU, deal with it, and then write back the changes or display it, etc., etc. And they've been working on dividing everything up inside their game structures into identically sized payloads, so the same number of bytes. I can't remember what the number was, but it was something on the order of a few hundred bytes. It was probably 255 bytes or something like that. So quite small. And because I'd spent a lot of time doing backends for massive multiplayer games, I'd become an expert in network programming. I'd implemented TCP/IP myself. I'd implemented lots of algorithms on top of UDP. I'd done a lot of packet optimization and packet routing, debugging of all that stuff. So all the things they were doing with this streaming of packets of data, I recognized and I understood, and I found it very easy to chat to them and see what they were doing. But talking to a couple of that team, especially a colleague at the time called Joel, realized that you could put these two things together. Joel was already talking about it and calling it an entity system or a component. I think he was calling it a component system. And he was just thinking, or not here, but the team he was in, they were thinking of it, as I said, just for performance reasons, for streaming reasons, and saying that every component had to fit into an identically sized packet, because then it was easy to think of an architecture that would be able to cope with all that and be generic. They could write it once and use it across multiple games. Whereas I was coming in from the perspective of, well, I need a way to be able to cut up classes and objects into reusable, attachable pieces. Ideally, I wanted to do it at the pointer reference level, so there's minimal overhead. And between us, I'd actually credit them more with it than myself, much more. I think it was 80% from them or 90% from them and only a fraction from me, starting to put these together and say, if you put all this together, this really works, probably. So that, I think by the time I left Codemasters, which was 2006, I'd got the theoretical idea for how something like this could and should work. And it wasn't until my next company where I finally figured out the real version, the more nuanced version, and the one which made it all fit together neatly.
So what was this third company?
So my time at Codemasters was amazing. I worked for an incredible manager, a guy called Jay Scott, who had come from Rockstar and manage one of their studios for them. An amazing manager and leader and mentor. But Codemasters at the time was a horrendously abusive company to work for. And he resigned, and they left us with no manager, team of about 50 or 60 people. We had no manager at all for, I think it was about a month. And there was a lot of recrimination, a lot of suffering. And as a result, all sorts of weird, horrible things happened, most of which I think is probably wisest I don't talk about on record. But net effect is I one day got summoned into a room, threatened with being beaten up, and marched out of the building and told, "You're fired, don't come back in." I found out later that rumours of what happened to me affected their hiring for the next 10 years of people refusing to work for Codemasters because they treated me so badly, which I felt was a good revenge on them, although it certainly wasn't in any way planned. I'd been working at this company with great people, with colleagues I got on really well with, a bad management running the company, this great senior manager leading our local part, who had then himself been basically pushed out, and the whole thing had fallen to pieces, and I'd been, in a somewhat terrifying manner, kicked out of the company. I have no idea what I'm going to do. And then NCSoft, who had just started their attempts to do, so giant MMO publisher from South Korea, who'd just started their attempts to do development in Europe, were saying, "We'd really like you to come and be a developer working for us." They seemed nice people, and I knew NCSoft was a very great reputation company within the MMO world. I was extremely excited to go and see how, one of the market leaders did it. At the time, they owned, I think, 3 out of the top 10 global MMOs by revenue. So great opportunity. And I went there and I turned up and I was like, "Great, so where's the development teams?" And they're like, "Well, you are the development team. You're the only engineer in Europe." There was about 100 staff, I think, but they were all sales and marketing because it was a publisher. And I was working with one designer and one project manager, who both were very experienced in their respective things, with long careers in shipped titles, AAA titles, etc. And at that company, we were given a remit to create an effective development system in Europe for this giant publisher, internal studios, whilst also working on external publishing. So we were funding or choosing which external game developers, game studios in Europe to invest in, and which titles to invest in. Each of us had other duties on the side, and mine included setting up shared core technology across Europe, across the external studios and for our internal studio, and start hiring people to work on this internal technology development. So I ended up doing a lot of strategic work on what should a core technology look like? What should shared technology look like across a big publisher, a big international publisher? We had a lot of very strong technology in Seoul, in South Korea, which was being used in Korea and China, I think, but nowhere else. It was the stuff that had originally been written by NCSoft when it was a very small company, and just layered upon and layered upon and layered upon. And so it was very good and it was very performant, but it was also very narrow in scope. It had been built to implement just the kind of games that were being designed in Asia at the time. In North America, we'd acquired something like 3 different game studios, each of which had their own unique take on technology and had each done it in different, incompatible ways. Some of them were weak, some of them were over-engineered. So they were all good and functional, but they all had their own problems. And in North America, they were trying to unify that on a shared thing that would work across all of their backends. And this is the same process that companies like EA had been going through at the time and continued to go through. So it was a recurring problem for big publishers, the multinational publishers across the world, was how to unify game engine development across all your different studios or different countries. So my take on that, I dug out my old thoughts on component systems, as I think I thought about at the time, and I went looking around at what everyone else was doing and what the latest thoughts were and so on. The things people were saying and the things people were trying and the things that were failing. At that point, I had a lot of things I could see that had failed. So I'd seen stuff that failed in the studios I worked at the studios I was working with, at the external studios, at the internal studios. I was part of quite a lot of professional networks of game developers at that point, and I spent a lot of time reading other people's postmortems on their attempts at doing shared technology or core technology and what had failed and why. And generally speaking, core technology failed for most games companies. This is by mid 2000s, late 2000s. Most game technology attempts failed. It's a really difficult thing to do a shared technology that will work for all your games and be fast enough for all of them. So then I started pulling these together and going, okay, what is the correct way of doing a general purpose, composition-based engine that is able to do everything any game needs? But in particular, I care about massive multiplayer online games. That's what my employer does. That's what we do. And I've got an opportunity to design something here that would work across our future games. I didn't think an ECS would be appropriate for NCSoft. I thought it was too cutting edge and too novel. And they had, in Korea at the time, I think we had 2,000 engineers working on our technology. So the idea that one guy in Europe could think up something that would in any way improve on what a team of 2,000 was doing was ridiculous. I didn't think of that even for a second. So this became more of a side project for me, a hobby project I did at home rather than anything I did as part of the company. Although, had I realized back then what I know now, I would have probably pushed very hard to make it, this is what the company should actually be using day to day. But then in doing that, I pulled together what ended up being the three core ideas of the entity, the component, and the system, improving, as I thought about it over the months, improving on the original ideas and reinserting a lot of computer science into it. So the two big observations that I think improved it were firstly that the entity is just a number. In computer science terms, it's just a label. It's nothing more. And so it might as well just be a number, or even, just as a number. Why not? That's generally the highest performance thing you can have in computing. And that your programming system you had with an ECS is essentially functional programming. ECS is really a way of doing functional programming inside an OOP language without losing any of the benefits of either. That's a theoretical and conceptual way of looking at it and is largely true. It's got lots of positive side effects, so it makes ECS inherently very easy to make high performance, just as any functional setup is, because especially when you look at server side and you have lots of parallel processors available, it's very easy to parallelize any functional programming code. Much more difficult to parallelize imperative or traditional OOP code. So, well, it's great for performance. This is even before you start looking at the stuff around streaming to CPUs and from memory, although that was a nice bonus. It's got a lot of things about cacheability. It's got a lot of things about which help on the server side, which then port again across to the CPU. Your CPU performance is often about cacheability more than anything else. So it ended up just being this collection of positive things that when you put them all together, they all work exceptionally well. I know since then, a friend of mine, Richard Lord, who wrote the first ECS things for JavaScript, he and I have agreed for years that it is that summary of it's a way of doing functional programming inside an OOP language is a fairly highly accurate way of summarizing it, but it's more complex than most people will be able to get their head around. Most people, and this has changed, Rich and I have both been quite strong proponents of this functional inside OOP. That's what ECS is doing for you. But for you to appreciate that, you need to first love functional programming and understand what's good about it and what's bad about it. And you need to have quite a deep understanding of OOP to understand what's bad about OOP. People are normally only ever told what's good about OOP. Now, in the last 5 years, that's changed. And a lot more people have come to realize that functional programming is a very good thing in and of itself and should be used in live production systems across all industries, rather than just be an obscure piece of academic theory, which is what people used to think of it as. So I think these things, although they were novel 10 years ago, nowadays I think it's quite normal and unexciting to say that you're doing functional programming on a commercial project or on a game project. All that stuff coming together was what then led to me going, right, this is what an ECS should be. this is what it's useful for, this is why it's great, this is why it's amazing, and then just talking to people all over the place. I reached out to the guy who wrote the Dungeon Siege talk at a GDC way back. So that would have been Scott Vilas, I believe, off the top of my head. And I asked him at the time, why is it that nobody cares about this? This seems to me, to be the biggest thing in the games industry. We should be doing this. We should be making this change. I tried to get talks at conferences, and nobody seems to care. So Scott just said, well, you should write a blog. Start a blog, see what happens. Get the word out there, and after more people understand it, then you can go to places like GDC, and the conference organizers will let you talk. I was like, great. So I started a blog. I wrote a couple of blog posts that were deliberately quite provocative, because the entire goal was to get enough noise made about this subject that we'd then be taken seriously by conference organizers, and then we could finally give conference talks on it, and then big games companies would finally start adopting it. That was the hope overall, although I didn't really expect it to work, but I had no better ideas, so I ran with Scott's idea on that one.
So if I understand, everything kind of originated on the backend side in your case. You were trying to run the simulation on the backend in this ECS framework. And you know the history also brought ECS on the front end side. Do you think this is kind of a logical progress for ECS, or?
Yeah. The reasons that ECS was an obvious, easy win on the back end. Number one, your back end is highly horizontally scaled. You can always add more servers. You can always add more CPUs. Always, always, always. And in general, if you're trying to scale up any tech business, you will add many CPUs and many servers. Oh, of course, most of this work predated the existence of Amazon AWS. So you couldn't do cloud computing back then. You had to build your own servers. So adding a server was not trivial. It was quite a bit of work, but it was still the only way you could increase performance beyond quite a low level. So everything was about how do you go more parallel. And when you go more parallel, your next problem you run into is you can't put much memory in any individual machine. So the total game state has to be distributed across many different physical machines. And the latency of moving game state from machine to machine becomes your limiting factor, which is what led to all sorts of things like instance dungeons in MMOs, because there was no other reasonable, realistic way of getting the data there in time on the back end. But those characteristics neatly map to what happened in desktop computing development over the last 20 odd years. A movement to, so CPU speeds haven't really changed much in the last, 15 years? They used to go up hugely from year to year, but they've kind of plateaued, and they move very slowly now in terms of increase. What we see more of is two things continue to grow at a fast rate. One is the amount of RAM per machine, and the other is the number of cores inside a desktop CPU. So it's normal now for a gaming PC to have 16 cores or 32 even. That was always likely possible to happen on the client side. I think over a long enough time frame it was inevitable, but nobody was sure quite quickly it would happen. The other thing is that in your single core performance in a modern CPU is driven by how quickly you can get stuff out of RAM and onto the CPU. I think it was the 486 was the last desktop computer that had the CPU and RAM running at the same speed. So that was 25 years ago. For the last 25 years, CPUs have run much, much faster than RAM. So any attempt to read anything from RAM is inherently slow as far as the CPU is concerned, which is the same as on the back end, where your attempts to read from RAM, if it's RAM on the same server, fine, but more often than not, it's RAM from a different server. So the performance problems you're working around in both places are, at an abstract level, the same. Obviously, in reality, they're very different in all sorts, many, many different ways, but the fundamentals are very similar. So I think it was a very natural transition. And as I mentioned early on at the start, the first time I really got into the performance side before coming up with the ECS core concepts was working with a PlayStation 2, PlayStation 3 programming team. And because of the nature of the way the PlayStation 3 had designed, it had been given a 6-core architecture. So the only way to make it run really fast was to copy a lot of these techniques from multi-core servers around parallelizing your data and your execution, and being very careful about being able to shift data from RAM to the local caches as quickly as possible and not have any slowdowns there.
So let's go back to your provocative blogging. So what happened after that?
Well, Unity was published in the early 2000s. And since the late 1990s, people had been talking about component-based games and component-based game architectures and entity-based architectures and entity-based games. Nobody knew what that was. Every single game studio made their own attempt at it. And really, the only thing anyone was working off was the original Thief games, where one of the later ones, I think it was Thief 3, had a entity system, a very simplistic entity system, where they had, for instance, wood, which had the property that it could burn and that it could float. So when you knocked a mesh into the water, if that mesh was marked as being made of wood, the game engine would make it float rather than make it sink. Whereas if you knocked a human body into the water, the mesh would sink to the bottom of the water. And this was amazing. Game designers thought it was the best thing ever. But it was so incredibly difficult to implement with any level of performance that every studio tried to do it, and nearly everyone failed. And there were a couple of broad approaches people took, which kept failing. There was a couple that didn't work so badly, but really didn't work well. And one of those was Unity. Unity's approach was not unique to Unity. A lot of game studios did exactly the same thing internally, and it worked well enough. And they carried on making games like that way through the 2000s, early 2010s. But by about 2010, a lot of the games industry felt that anything with the word entity or component in it was a failure, because many of them had tried an attempt because nobody had defined what was right or wrong or what entity component system actually meant. A lot of approaches people tried architecturally were doomed to failure, could never work. They just, performance-wise, they were always going to be slow. And so Unity often got described as an entity system or as a component system because, when it was originally developed, that was true. But by around 2010, I and a bunch of other people had started saying, no, we've come up with a definition now, this entity component system. And Unity definitely is absolutely not that in any way, shape, or form. Unity is one of the dead-end architectures that people tried. It's not bad. It was a good idea at the time. It was a good idea. It was a good thing to try. But with hindsight, we now know collectively as an industry, they don't really work. That's fine, but it would be great if Unity actually adopted a real ECS. And then, of course, about 5 years ago, Unity finally made a similar decision and started the DOTS, the DOTS project, which brings a true ECS into Unity. By the time they did that, the ECS had already become industry standard, widely known. I think the majority of indie games were using an ECS approach. Big studios had started adopting it quite happily. I'd been receiving emails in 2013, 2014 from friends in other big AAA studios saying they were starting to use an ECS internally in some of their live console games. They were using even databases internally, in-memory databases, to store and implement the ECS, which was something that we'd always theoretically talked about, but in the mid-2000s, the performance of an in-memory database was a bit too slow to do that in real time. So I think when Unity adopted it, that was basically, it's gone totally mainstream by that point.
So what was your feeling at that moment?
It was awesome. It was a thing of, I never thought when I started it I've managed to get that much popularity. I dreamed, I hoped, I thought that's impossible. Who am I? I'm just one small person. I'm not going to have that level of impact. And I also thought from my early attempts at it, just over and over again, no one seems to care. The people who should care, people in studios, people running games conferences, they just kept saying, this is irrelevant. It's unimportant. Nobody cares. No one will ever use it. Why does it matter? This is pointless. And I felt quite, well, I know they're wrong, but if they're all wrong, but none of them believe me and none of them can see it, it doesn't matter. Nothing's ever going to happen. So it was a relief about 2015 or so to be able to go, yes, it's definitely, I was right. I wasn't an idiot. I wasn't insane. This was the right thing for us to be pursuing. Although, obviously, along the way, I learned a lot about how you should and shouldn't educate or try to educate an industry or evangelize to an industry new technology, which I think is a whole massive subject in itself. And I'm still very much a beginner at, but that's a whole complex thing.
Have you been able to push ECS within the walls of NCSoft, or?
No, so sadly, I left NCSoft before we managed to get to do anything significant with that. And I went off and then spent many years building mobile apps. So iPhone had just come out and just the App Store had started. And I saw so much opportunity to discover what makes a good app and learn to build them and learn how to build them and design them and so on in an environment where nobody knew what makes a good app. Nobody knew what was good or bad. So it was a level playing field and we could compete as individual contractors against giant companies. So I spent about 7-8 years as a mobile developer doing native Android and native iOS and used some ECS concepts on some of those projects, but rarely. Mostly because mobile apps rarely get to anything like the complexity where you start to see big advantages from that. Most of the time, the priority with the mobile app is to be developed quickly. And although an ECS could definitely speed up your development time, the problem was we could never quite justify the investment cost to go and build a complete ECS architecture at high performance inside native iOS, because that would mean taking time away from actual paid work we were doing for brands and big companies. So we did a few small things there, but nothing big that actually got published. And then, of course, Unity announced their DOT system. And at that point, we stopped most of the development on third-party ECS systems because the ideal was for a giant company, a billion-dollar company like Unity, to take on the engineering cost of doing that and do it well. I have to be careful on this because it's very easy to be blinded by your own biases. It's very easy to accidentally become the person in the old adage, when all you have is a hammer, everything in the world starts to look like a nail. For instance, in the company where I currently work, one of the core directions we're taking our technology and our stack, which I can't talk about because I'm afraid this is non-public yet, but one of the core directions seems like we might end up implementing it using a complete ECS. And this is in the finance industry. It's nothing to do with games. It's about as far away from games as you could get. But issues around large volumes of data, the need to process them very quickly, very optimally. And when I say large volumes, I mean I'm talking massive volumes of data, terabytes of data in some cases. In some cases as small as gigabytes, but a lot of the time terabytes. And all of it needs to be accessible very rapidly in real time to the user. And I've seen some very interesting overlaps there between the stuff we're doing there and things like Elasticsearch. A lot of how the ELK stack approaches data looks like it can fit in very neatly with an actual ECS system. So one of my planned hobby projects sometime in the next year or so is to try implementing ECS directly on top of ELK and see how easy or hard that is. Because I have a theory it could be a very fast way to get a new proprietary ECS up and running, but doing it on leveraging a shared backend that you could use across, you can deploy across lots of already industry standard hosting solutions. If someone else wants to try that or already has, I would love to talk to them because for me it's still a future idea of a thing to play with. It's not something I've actually gone through with yet.
What is in the stack, the ELK? So there's Elasticsearch, Kibana.
Yeah, exactly. Yeah, Elasticsearch, Logstash, Kibana. So ELK. Elastic is your underlying search engine. Logstash is the bit I hardly ever use, but that's the bit that's designed to help you frame getting data in and out of it or mostly into it in a clean fashion. And as revealed by the name, it was designed specifically for trying to get logs into that. So application logs of user clicked on button, user logged in, user logged out, etc. And then Kibana is the visualization dashboard system that sits on top and it draws pretty graphs for you. but it draws many, many pretty graphs. It's very easy to slice and dice your data and look at it in different ways. So I think the interesting thing, if anyone's playing with ECS on this, is looking at how much of Logstash is compatible. But I think my assumption would be ignore it and build your own. Build something on top of Elastic, but then seeing how much of that you can expose to Kibana, because Kibana is sitting there basically begging to be an incredibly powerful, half pre-built visual debugging situation for you for your entire ECS lake of data. And it's all open source. So all lovely to work with.
Okay. Did you have any chance to try the ECS from Unity itself also, or?
I've never used it on an actual shipped title, or nor even tried to use it on a shipped title, because every time we've looked at it, it's been not production ready by a long way. I've played with it for toy projects, for simple things, and the early versions of it, I was like, yeah, great, this is mostly correct. There's a lot that's wrong with it, but I think those are teething pains. I think those are things that the teams building it already know exactly how it should work and how it shouldn't. I felt, especially in 2019, just before lockdown happened, so I went to Unite, the Unity conference, and I was surprised there were quite a lot of people complaining about dots there, especially saying it doesn't work well, it's difficult to write the code, it's clunky, it's ugly. I felt they missed the point, which was the places where it was clunky and ugly were obviously the temporary shims, the bits that were necessary while they're switching over from their traditional Unity into an ECS thing, or the bits where it was the less core parts of Unity. So they were just using temporary first draft implementation rather than the ideal long-term solution. I felt that the very core stuff worked very neatly, and they'd come up with a nice paradigm for how you code against it, which was one of the things I've always made a lot of noise about, which is that if your ECS requires you to do a lot of typing in code, like typing a lot of characters, then you've screwed up, because so much of it is deterministic that your IDE and your programming language should be able to provide almost all of it for you. You should only be needing to type the few characters that are necessary to distinguish exactly what you're intending and exactly how you want it to work. But you sometimes see ECS implementations that require 12 words separated by dots to access a single local variable, which is insane, because that should be a single word, or two words with a single dot, or a single indirect operator, something like that. And it's very easy to come up with a verbose implementation of an ECS. It takes a lot more effort in any given programming language to come up with a clean, neat, concise wording for how people access and use it. But I felt Unity as well was certainly going in the right direction with that. And I felt that it was leveraging C# features quite nicely. Obviously, it's all exposed in C# in Unity. But they recently announced that they're kind of giving up on it, which is a bit sad. I'm guessing that's just because now that they're a public company, they have many different things they have to focus on, and they're having to slightly reduce the amount of time and money they put on the on dots. So I don't know what's going to happen to it now, and I haven't played with it in the last 12 months, mostly because of COVID and lockdown. I've been focusing on a lot of other areas of Unity and just waiting for dots to be declared production ready, which, as I said, it really absolutely isn't at the moment. So I'm watching that space, eager to see how it turns out.
From what I know, they actually, it's still not ready, and it won't be ready in a couple of years, I think. And I think they are on a way where they are going to actually have two products somehow. One which would be...
You see, I have to say, that is insane. It is simply insane. And it's one of the things I know is driving a huge number of expert developers away from Unity. This is not the first insane thing they're doing. The other insane thing is scriptable render pipelines, which has just been incredibly badly managed and handled by Unity as a company. It's been total chaos. The original great idea that came from Aras has been ripped to pieces and turned into something horrendous. And I see Dots is starting to look like it's about to suffer the same thing. There is no reason that Dots needs a couple of years to be developed. There's just no reason. The only reason for that is that Unity can't sort out their internal politics, and they've got internal reasons why they're refusing to actually finish building it, of which I know there are many. And it's a giant company, and there are many, many teams and many, many different products they sell at the moment. So Unity, the programming engine, isn't even a product they sell. What they sell is all the things built on top of it, of which I think last time I looked, dozens of different products. They sell to different industries, lots of non-games industries, for instance. And a lot of people who develop with Unity aren't even aware of things that are out there. And there's some obscure but exciting stuff like Mars that a lot of people have never heard of because they just don't notice it. But Unity as a company is distracted by all of those things. And so I can see why Dots is being delayed, but it's essentially Unity as a company collectively saying they're not serious about Dots anymore. And to have a two-tier engine is, I think it's extremely dangerous because it opens up the possibility of, for instance, another famous engine company beginning with U, but they're not the only one, just walking up and providing a commercial, robust ECS implementation, and Unity hemorrhaging developers, because this is something that people have wanted and have been using for many years now, and Unity has still failed to provide it. But the performance and the design benefits are enormous. And I felt Unity's done enough of the hard work now that what's left is not being held up by technology problems. I find it very hard to believe it's anything other than political problems.
Okay, I see. How about we switch to another facet of your career? Because I know you're also, a lot of it is also about people and team management, right? So what actually brought you into the subject as well?
When I first got interested in technology and computers, I noticed that great products, great technology often failed in the market. And as a mathematician and as a very technical person, I found this very frustrating and borderline upsetting, painful. So I made it a quest of mine, even for my teenage years, to never build any technology that then fails in the market for the wrong reasons. If a technology is bad, that's fine. It deserves to fail. But if it's good, if it's great, it doesn't deserve to fail. And my first observation was that marketing was often the reason why good technology didn't succeed. Weak technology with better marketing nearly always beats better technology with weak marketing. So I tried to learn a lot about business and business management because I never wanted to feel that I invented a great technology that the world didn't use because of something as stupid as poor marketing or poor sales strategy. That led to me doing quite a lot of tech leadership positions early on, swapping between jobs between being mostly programming and being mostly managing, learning how to manage by trial and error, as most people do, sadly. I spent a lot of time in tech startups. I spent a lot of time working with tech startups when I was working with the funding societies at university and afterwards. But then also I then went and founded a startup. I then worked in other people's startups. I witnessed some big successful startups. And I noticed that there was a recurring feature. In startups, it's a very, very high risk business. When a startup fails, it's probably not because you did anything wrong. It's probably just bad luck. But as an engineer, obviously you look for, well, what can I control? What does make an impact? Let's make sure we do the right things and at least weight the probabilities in our favor. And I saw over and over and over and over again that the one thing that consistently had more reliable impact on a startup's success or failure than anything else was the culture, the team culture. How those people talked to each other, how they felt about each other, how they reacted to each other, how they supported each other, how they interacted with their managers, how they interacted with other people in the company, what the politics were. Was it positive atmosphere? Was it negative atmosphere? Just all the things that we typically summarize as company culture, or the other ones we summarize as team culture. And so I spent years and years trying to get better at understanding culture and at fostering positive culture. Along the way, because that means you end up asking for budget, or you ask for your manager to not do something that the manager thinks would save money, or you ask them to do something and that's going to cost money, even as simple as running a away day for the team or giving someone some extra holiday. it technically costs the company money. Normally, it costs the company such a tiny amount of money, it's irrelevant. But because a lot of managers are self-taught, a lot of managers don't realize it's irrelevant, and they worry that they're spending someone else's money. So along the way, I had to build up a lot of techniques in how you persuade non-engineers, non-developers, and in games companies, non-games people of the value of these things. So spending a lot of time looking at how you phrase things such that a finance director would understand, or a CFO, or an accountant, or how a sales director would understand. Because I would find myself in meetings with a CEO and a board of directors, and I'd get pushback from the sales or marketing director on, oh, but that's a waste of money. You wouldn't let me spend money on the sales campaign I wanted or the marketing campaign, so why are you letting the engineering team spend money on that pointless waste of time? And I would need to come up with justifications that persuaded them. The more I spent time on this, the more I got better at it. But about 2 years ago, I realized in particular that part of that, which is getting the right people, obviously is actually the easiest, is the most effective part. If you can get the right people into your company, then having the right culture is inherently much easier. One of the difficult parts about that is when I say the right culture or the right people, it's hard to know what the right culture is for your company. It's hard to know what the right people are or what they look like. And normally they are nothing like what people assume they will be. Common mistake in a lot of the tech industries is to assume the right people are people who think like me or who look like me, even down to physically looking like me, which is incredibly foolish, but it's a very natural human mistake to make. So I don't want to brush over the fact that it can be very difficult to figure out what right is in your particular situation. But once you've figured that out, if you can hire the right people, you make all your cultural problems easier to deal with. And then you enable yourself to magnify your team's success and your company's success through your positive, correct, appropriate culture. So I realized, well, hiring is possibly the most important thing I could actually be doing at a company. I looked around and I found that every time the CEOs of Fortune 500 companies are interviewed about what's the most important thing you do in your job, what's the most important thing you could be doing, they say hiring, finding the best people. And at the opposite end of the scale, VCs, venture capital firms, when they're interviewed about what's the most important thing you invest in a company, they always say the founding team, the people. And when they're asked what's the most important thing a CEO could be doing with their time, CEO of a startup, often the answer is hiring better people. So we have this strange situation where everyone seems to agree that hiring is very, very important, possibly the most important thing you can do to achieve the success of your company, beyond the obvious tactical day-to-day stuff. And yet, most people aren't. They aren't putting much time into hiring. They don't put much effort into it. If you look at any given manager and ask them, how many hours a week do you work? Okay, and how many of those hours are purely spent on hiring? The answer is generally not impressive. And the higher you go up a company, often the lower that proportion gets, which is even more worrying, because as you go up the company, that proportion should increase, not decrease. All of that's led to me having quite a kind of, originally a strong interest in hiring, but now it's gradually turning into more like an obsession. This is my next big quest, is get the world to become much better at understanding hiring and using it more effectively and hiring better. Hiring the people you need rather than the people you think you want. Because it's good for companies, it's good for the existing employees because they get to work with people they work with, they get on with better. And it's good for candidates because so many times good candidates get skipped over in the hiring process for the wrong reasons. And everyone loses when that happens.
I know you're writing a book on it, right? So what's the status on it?
I thought I would write a book and it would be 15 to 20 pages long. It would be a PDF. I'd stick it on my website and people would just read it. Fine, that's it. And I thought, I don't have much to say. I don't know much about hiring. I've always been quite bad at it. I just try to borrow the best things of everyone else and learn as I go. And when I sat down to write it, I discovered I had about 120 pages worth and that I had so much more to say. And that 120 pages, I looked at it and thought, actually, most people who need to read this they won't understand half of this because it's all correct and it all makes sense, but it requires you to have a lot of insight for you to use this information effectively. For instance, if we look at theoretical physics, I can tell someone E equals mc squared, and anyone can read that, and you can tell them E is energy, m is mass, and c is velocity, and c in particular is the velocity of light in a vacuum. Totally, anyone can understand that. Now, ask someone to do something useful with that information. Absolutely no chance for most people. They don't have anywhere near the background knowledge or additional information to be able to do something with that equation. And I felt, obviously, my book was nowhere near as advanced as that formula or theoretical physics, but I felt that reading it, most people who would need to read the book they'd read it and it would make sense, but they wouldn't be able to do anything with it. So it would be a waste of their time and a waste of my time. So then I spent most of last year trying to figure out what I would need to write instead that would be actionable. They would get the same information from, but they would get it in a way they could actually use it themselves and build on it themselves and develop it and add to it and adapt it to their own situation. That obviously is taking a lot longer. So I suppose I'm at the moment where on that topic, I'm ready to write the new abstract of the book, the new chapter headings and chapter summaries and paragraph summaries. But that's going to take me a few more months just to finish writing that. And then I can write the book. And the book will then probably take another few months to write. There's about 6 months left to do on that. And that's assuming I stop work for most of that time. However, I wasn't willing to wait that long. Life is far too short to spend so much time writing a single book. So I started writing another book, which is apparently quite a common thing people do. And my second book picks one small part of the first book, just one part, one problem, and explodes that problem out and shows how in that one problem you can cover most of the important things about hiring. Not all, maybe half, maybe 60% of them, but you can do it in a way that people can actually use and build on. So the book it doesn't have a proper title yet, but provisionally speaking, it's going to be called something like How to Hire 2 Pizza Teams. And this comes from the Jeff Bezos quote that it's ideal to have teams that can be fed with no more than 2 pizzas. So that's teams of 6 to 12-ish people. No one's ever really characterized how many people are in a 2-pizza team. It kind of depends where you live in the world, how big your pizzas are, and how hungry your team are. So it's not a very good definition. But it's a well-known target. And what I've done is I've gone out and I've picked people mostly from my network, my extended network, who have been hiring and managing tech industry teams for 15 to 30 years. So some of them have been doing it for 30 years. A lot of them have been doing it for 20 to 25 years. I think the one that's done it the least has been doing it for 15 years. So these are people who have been doing it a long, long time, and they have handled individually. Some of them have hired thousands of people during their career and managed. They're not HR people. These are managers. These are senior managers. These are head of studio in the games industry. They are CEOs. They are VPs within large multinationals. So VPs of technology or VPs of software engineering, or et cetera, et cetera. So they're people who all the hiring they do is in service of having the people they need to create the product that they're shipping. If it's the wrong people, they won't be able to make the right product and they'll suffer. So they really care. And they have to manage these people as well. They're not hiring them for someone else, they're hiring them for themselves. So for each of these people, I've gone to them and asked a couple of questions around when you were a first-time manager and you'd got the hang of managing and you'd hired a few people, but then you got to the point where you realized you needed to hire a whole team. What did you think back then, which you now know to be false? And what do you wish you'd been able to tell yourself back then, given everything you know now? And the book is just their collected responses to those questions. And what's really interesting is they're very different, but they converge on the same themes. And on some topics, they almost all have the same answer, even though they have very different ways of phrasing it. And in that, I think, is the value of the book, is that as a reader, you'll be able to read each of the different interviews and find one that fits with your management style and the kind of company you want to work for and the kind of company you want to create. and then look at how that person views the world and what solutions they've come up with and what approaches and strategies, and use that as your basis for what you could be doing. I think the most important thing here is that, as one of the guys I interviewed said, the difficulty as a former engineer is that the compile, test, debug cycle for hiring is extremely long. Now, your compile, test, debug cycle in programming, you typically want to be measured in minutes. If it's more than minutes, if it's tens of minutes, you've got a problem. If it's hours, forget it. You're wasting your time. Ideally, you want it to be seconds. This is why a lot of modern programming is done in languages that don't require compilation, because it reduces your compile, test, debug cycle. It's awesome. It enables you as a human to get more done more quickly. The compile, test, debug cycle in hiring is measured not even in years, but in tens of years often, certainly in 5 years at a time. For instance, if you were just hiring a role and you've interviewed a whole bunch of people and you decided which one to hire, did I hire the wrong one? Well, it's going to take 2 to 3 years to know if the one I hired was a good one, because you have to see how they grow within the company, the effects they have, who else gets on with them or doesn't get on with them, do they cause other teams to succeed or fail, how do they grow as a person, how does their team grow, etc. But what about all the people you rejected? How do you know if you should have hired one of them and they would have been even better? Well, you have to watch that person, see what job they get instead, see what happens to them, see what happens in that job. And seeing as you don't work with them, you probably need to watch not just their first job, but their first 2 jobs or 3 jobs to see what pattern emerges. Because maybe in the first job they just got lucky or just got unlucky. But over 2 or 3 jobs you can start to see. So 6 or 7 years later, you can make a good call on whether you chose the right candidate for the job, the best one out of the ones available to you. But that means you need 6 or 7 years just to know if your very first hire was the best you could have done. How long before you actually get good at it? Well, we're looking at more like 15, 20 years. And I think that's why it's so interesting to interview these people exclusively who've been hiring and managing for such a long time. Hopefully other people will find that interesting as well. This book is almost finished. I've just got a few more weeks of writing left to do on it. And I just need to fit that in around all my other commitments. And then hopefully it will be done and people can read it.
Okay. Do you know already how you will distribute it, or?
Not sure. No, sorry. I'm totally, in terms of being any kind of professionalism as an author, I'm terrible. I just treat this as I'll write the book and make it good, and I'll worry later about whether I can actually get people to read it or not. I will stick it up on Amazon as an ebook, so you can get it on Kindle, PDF reader, whatever. I will probably also put up a website. I've got a website for it, but it's got all the information is out of date. So I'll at some point update the website and probably make it available to read off the website as well. I'm thinking I will probably put up the first 3 chapters as a free download so people can see what they're getting. And I expect to charge something like $15 for it, but a token amount. Could be $10, could just be pay what you want. I'm not expecting it to cover the cost of writing a book. It's more that if you don't put any money on it at all, people don't take a book seriously, unfortunately.
I was a bit curious on how you managed to do so many things. You mentioned 2 books and you have a full-time job and such. So what are your secrets and tips to be productive, basically?
So for a good 10 years, maybe more than 10 years, I had a habit of doing a normal amount of stuff and then taking on about an extra 10%, 20% commitments and working hard, and then taking on, because that was going okay, I then took another 30 or 40% commitments. That was very intense and exciting and felt amazing for all of a week or 2 weeks or 3 weeks. And then I probably took on another 10% during those 2 or 3 weeks. And then I just crashed because I was trying to fit in twice as much as I should have. And then I would go back to doing just a normal amount until I got too frustrated that I wasn't doing enough. And then I'd take on more and more, and then I'd crash. And it would just repeat over and over again, this cycle. The cycle time could take 6 months. So it could be quite a long, drawn-out process for this to happen. Or it could take a year or more. Or it could take just a month. So that definitely happened to me a lot. And I say it happened to me a lot. It was obvious when it happened, and it was painful to me. So it's the one that's big in my memory. It probably didn't happen that much in percentage terms. It was maybe 10%, 15% of my experiences. I think 50-60% of my experience has been just getting very focused on doing one thing at a time. So you get very focused on it and you push it forwards very, very, very far in one burst. So, for instance, last weekend, I was trying to get a update out for a Unity plugin I maintain that implements CSS Flexbox inside Unity. I was planning to get up on Saturday morning at about 9 a.m., 10 a.m., have a relaxed morning, and then spend the afternoon, 1 p.m. till 3 p.m., just finishing off a few fixes, and then maybe an extra half hour to get it published. And instead, what happened is I woke up at 5 a.m., partly because my brain I was so stressed with am I going to get this done in time? I lay awake for about 10 minutes and then realized I'm not going to get back to sleep. I just want to get on with finishing that code. It's only going to take 2 hours. So I want more hours of sleep, but fine. I'll just get up. I'll do it now and then I'll go back to bed. So 21 hours later, 4 a.m. the following morning, my eyesight had gone blurry. I could barely remember my own name. And I was like, right, fine, I'm just going to stop here. And I'd done a lot more than I was intending to originally. But I discovered some deep problems and investigated them in detail, done a huge amount of debugging, found a solution, implemented that solution, implemented a refactoring of a big chunk of the code, and fixed another project which had been suffering from this, which I hadn't realized because it inherited, or it was reusing some of that code. Which then led to me fixing some other problems in the second project. And then I gone back to the first project and tried to add a few more features I desperately wanted in there for ages and just hadn't had the time to. But now I was here, I was like, fine, I'm already working on this code. I'll push it through. I'll make this work as well. And I kept on that until I hit some nasty problem. And for about 2 hours, I tried to work on that problem. By that point, I was so tired. It was taking me 2 hours to do what normally would only take me 20 minutes. At that point, I went, it's time to sleep. So went to bed, and the next day, after about 9 or 10 hours sleep, I did indeed solve in 15 minutes what I'd failed to solve in 2 hours the night before. When you try these long stretches, they waste time. They waste a huge amount of time. They become very inefficient towards the end. And unfortunately, all the studies on sleep deprivation and exhaustion and so on show us that no human is capable of noticing that their productivity has dropped until a long time after it's already dropped. So you waste a lot of time before you are even aware you might be wasting time. In the mid stage, before you get to that point, your productivity is extremely high because as a programmer, the working set is all in your head. You've spent a few hours refamiliarizing yourself with the code base, what's in which files, why does it work, how does it work. You've just done a load of debugging of different bits. So the whole model is all embedded in your brain right there, very fresh. And that's when you are super, super productive. The more time you can set aside at that point to just get stuff done, the vastly more performant you'll be than any other point. The prize is to find ways of working getting the time and the space to focus so that you can ramp up to that high performance level, but then find a way to stop or have something else stop you before you get into the down ramping, where it takes you so much longer to do something that it was better that you hadn't even tried it. I know lots of different people have lots of different approaches to that. One in particular that I recommend, it doesn't work for me, but it's worked for a lot of people I've seen, is having a significant other, boyfriend, girlfriend, husband, wife, who keeps an eye on you, because it's normally quite easy for someone else to tell when your productivity has dropped, just watching you in ways that you can't tell. It's like watching someone get drunk. Past a certain level of drunkenness, people can't tell reliably how drunk they are until they get very, very drunk. What I've described is common amongst engineers, it's common amongst game developers. I think the bit that's useful is just embrace it, but find ways to discover that point where you're starting to lose productivity and stop there. I think the rest of, I said that's about 50% of my experience. I think the other big thing, that's about 30-40% of my experience, is always trying to find the underlying principle behind whatever you're working on. There's a saying, work smart, not hard, which I particularly like. The idea being, if you've got 8 hours of work to do, try and figure out a way of cheating, shortcutting, so that you only spend an hour doing it. If you do that, then you've got 7 hours of free time. I've seen it described as try and be lazy at all points, especially as a programmer, which is fine, but you have to understand the subtlety of why you're being lazy. It means that you invest a lot more time up front on everything you're doing. Because if you've got 8 hours of work, it might take you 2 hours to figure out how to reduce that to 1 hour. So you still end up spending 3 hours in total. But still, you've saved more than half the time. And most people don't have the courage to invest that time up front. They get scared that they're wasting time on something pointless, that spending 2 hours up front, it will still take them 8 hours to do the main thing. So it'll end up taking longer than if they hadn't tried to plan it out. More than anything else, that's where I've saved time. I've saved time for my employers. I've made projects get shipped much sooner, but I've saved time for myself. I've made so much extra time by putting the effort into that fundamental understanding that then lets you make lots and lots of shortcuts later on. So that's the one that I would probably focus on. The other one that applies to me in particular is a social life gets in the way of having a productive life. And for me, I have a limited amount of energy for social interactions. So I'm very socially active, and I will have very intensive social few days, and then I just won't want to see anyone for a while. And when I don't want to see anyone, that's a great time to get on with all the other stuff that I want to be doing. And when I get my head is aching, my eyeballs are unfocused, and my brain is swimming with code problems, and it's just incredibly stressful, it's great to then just stop and go off and do some socializing again. And I find, for me personally, flip-flopping between those two has enabled me to maximize both. Where for many, many years, I was told you should find a balance of do some of one, some of the other, some of one, some of the other. For me, that doesn't work. For me, it's do one intensely until you can't stand it anymore, then do the other intensely until you can't stand it anymore. A lot of this, I think, comes down to caring enough to find the ways that you as an individual can get your highest productivity. And a lot of people don't care enough to try, or don't try hard enough, or unfortunately I have some friends who care very, very much, but they're not willing to experiment. So they'll read one book that tells them how to be more productive, and they'll try what that book says, and if it doesn't work, they give up. Whereas I think it's more of you have to try something, and then try something else, and then try something else, and just keep experimenting with different ways of working, of living, of dividing up your life, dividing up your time, prioritizing until you find the one that works for you. I think there's one other part I would add on top of that, which is being interested in things. Find it very easy to get very interested and very excited about things. And I generally don't do stuff I'm not interested or excited by. The minimum barrier to me is to be actually excited by it. I find that if you have an open mind, you can normally find something exciting about almost anything. If you're not excited enough to start with, it's difficult. It's very difficult to force yourself to do these things. But if you are excited, it's almost effortless. It just comes easily. And I think my very start with becoming good with computers was I played lots of computer games that were buggy and broken. And I learned how to fix computers because my motivation was I want to play a game. I've got a game that's crashing or not working. I'm going to have to learn how to fix device drivers on Windows, which otherwise I would never have done because it's incredibly boring and stupid and a waste of your life. But if you've got a computer game sitting there on your desk that you've just downloaded, it's ready to play, and you can't because of a device driver problem, you are very motivated, and it's very easy to find the energy to do it.
I think I'm a bit of the same. So I try to compartment my time. Since I got kids, you wake up for the kids. I need to put the kids to bed. So I need a certain discipline anyhow.
They're not optional. You can't say, like, when you're like, I'm going to do this, and then at 1 o'clock I'm going to have lunch, and at 3 o'clock I'll take a break. Those could be moved. When it's, I'll do this, and then I have to feed the baby, you can't just leave the child on its own. Or I have to go and collect the children from school. You can't be like, yeah, I'll put that off another hour. I'm kind of busy right now. it makes it easy for you to stick to those compartments. I had one friend who, after having 3 children, I said, "How did you cope?" And they just said, "You just get very, very, very good at self-organization. You have no choice."
It relates to what you said first, right? You have to do things, right? Even if it's poorly made, you just have to do it.
But then you also, I think actually being a parent also teaches you to get better at finding shortcuts. And I think shortcuts is the key thing that a lot of people don't realize how many people who are productive are doing it by shortcuts. Those shortcuts are everything.
All right. It was great to talk to you.
Likewise. Thank you very much.
Thank you for your time.
Have a great day.
Bye-bye.
Goodbye.
Hit.